What if I told you that the real work of a geologist has almost nothing to do with collecting pretty rocks? What if it's actually about reading a story, an absolutely epic story, written in stone over millions of years, right under our feet? So let's be honest. Most of us picture geologists just, picking up interesting rocks. But the reality? Oh, it's so much cooler. It's like being a detective at a crime scene. The entire landscape is full of clues, and it's the geologist's job to piece together exactly what happened, when it happened, and in what order. So, let's just get this one big idea straight right from the start. This isn't just a hobby. It's a full-on intellectual adventure, and it has nothing to do with what you can stuff in your backpack and take home. This right here, this is the heart of it. A field geologist doesn't just see a rock, they see all of its relationships. See, a single rock by itself is kind of like a single word, pretty meaningless. But the landscape around it, what's above it, what's below it, what's cutting right through it, that's the grammar. That's what turns a single word into a full sentence. And that brings us to the single most important rule in our whole detective story. Seriously, if you're going to remember one thing from all this, this is the one. It governs everything else. Okay, so imagine you're out hiking. You find a cool piece of granite. You pick it up. It's heavy, it's sparkly. It tells you that, hey, there's granite in this area, which, that's something, but it's not the story. But what if you left that chunk of granite right where you found it, still part of that massive cliff face? Well, now it can tell you pretty much everything. Was it part of a giant underground magma chamber? Was it shoved up to form a mountain range? Was it later cracked by an earthquake? Its position, its context, that's where the story really lives. This quote just nails it. Composition is what the rock is made of, granite, sandstone, whatever. But context is where it is, and even more important, how it got there. That how is the entire plot of our mystery. You could have two identical rocks that tell completely different stories, all because of their context. All right, so if we're detectives, we're going to need a toolkit, right? Well, this next part covers the simple, totally brilliant logical tools geologists use to build a timeline of events. And the craziest part? They can do it without ever looking at a clock. The first tool sounds kind of fancy, the principle of superposition, but trust me, you already understand this intuitively. It's like a laundry basket. The clothes you wore on one day are at the bottom. The ones from Friday are right on top. Simple, right? The Earth's layers work the exact same way. Let's just walk through a super quick example. So an ancient seedbed lays down a layer of sand. We'll call it layer A. Millions of years go by. Then a river lays down a new layer of mud, layer B, right on top of it. The conclusion is simple, but it's also profound. Layer B has to be younger than layer A. There's no other way it could work. And our second tool is just as logical. I love this one. Think about it. You can't slice a birthday cake before you've actually baked the cake. In geology, it's the same thing. If a feature, like a fault from an earthquake, cuts through a bunch of rock layers, that fault had to have happened after the layers were already there. And here we see it in action. Over millions and millions of years, layers A, B, and C get laid down, one on top of the other. Then, bam, a geologic event happens and a fault, a big crack, rips right through all three of them. So what's the youngest thing in this picture? By definition, it has to be the fault. It couldn't have happened any other way. So you see what's going on here? With just these simple rules of logic, a geologist can stand on a hillside and literally start to read time. They can unravel a sequence of events stretching back millions of years and answer that one question that's at the heart of every single mystery. What happened first? So, what does a geologist do with all this information? All these observations and logical deductions? They don't just scribble it in a notebook. No. The final goal, the finished detective's report, is something way more powerful. It's a map. And listen, a geological map is so much more than a guide for how to get somewhere. When you start mapping out where all the different rock types are and how they relate to each other, these huge, incredible patterns start to emerge. You can suddenly see the ghost of an ancient volcano or trace the shoreline of a forgotten sea. A map transforms thousands of tiny little clues into one single coherent story. So you might be thinking, okay, is the secret having the best rock hammer or memorizing hundreds of rock names? Nope, it's not about any of that. There's a fundamental way of thinking that unlocks this whole thing. It really boils down to asking yourself one simple question over and over again. And here it is. This quote from the brilliant physicist Richard Feynman is the engine that drives all of field geology. It's a constant game of if-then. If I see these layers are all folded up, then some massive force must have squeezed them. If this lava flow cuts through that sandstone, then the volcano must be younger. It's this relentless chain of logic that allows you to read the story written in the hills. So, to bring this all together, I want to leave you with one final image, a powerful metaphor that I think just perfectly captures the true challenge and the absolute beauty of this work. I want you to imagine the complete history of the Earth is written in a book, a really, really thick one. Now, the first thing I want you to do is just tear out most of the pages. Huge chunks of time are just gone from the geologic record. Okay, now, with the few pages you have left, I want you to crumple them up into a tight, messy ball. That's what millions of years of continental collisions and mountain building does to the rock layers. And we're not done. Let's make it even harder. Spill some coffee on that crumpled ball, smearing the ink. Maybe even burn the edges a little bit. That's erosion. That's weathering. That's all the stuff that alters the clues over time. And after all of that, you hand that messy, incomplete, stained, and crumpled pile of pages to someone, and you ask them, "So, what was the story about?" That is field geology. It's the art of reconstructing an epic narrative from the most damaged, incomplete manuscript you can possibly imagine. And you know what's so amazing about all this? At its heart, it's just this profoundly human endeavor. Before we had satellites, before we had fancy labs and computer models, this entire field was built on the simple, powerful combination of just a person, a hammer, and a hillside full of clues, just waiting for someone to come along and read them.